Okay, illustrative math, Algebra 2, Unit 4, Lesson 18 is called Applications of Logarithmic Functions. All right, the warm-up here. Without using a graphing calculator, put the following expressions in order from least to greatest. Okay, so some of these you can kind of mentally do. So this is going to be 10 to what power equals 11. So that's going to be 10 to the first is 10. So this is going to be like 1.1 maybe, roughly. This is 2 to what power equals 8. So this is 3. 5 to what power equals 0.2. So it's going to have to be 5 to the first would give me 5. 5 to the second would give me 25. So it's going to have to be a negative power. 5 to the negative 1 is 1/5. So 5 to the negative 1 is 1/5, which is 0.2. So this one's negative 1. 10 to what power equals 0.01? That's going to be 10 to the negative 2. That gives me 1 over 10 to the positive 2, which is 1 over 100, which is 0.01. So this one is negative 2. And then, sorry, I kind of didn't leave myself enough room here. So then this is e to what power equals 1. So this is e to the 0. Anything to the 0 is 1, so this is 0. So in order from least to greatest. So least would be this one. So it's going to be, I'll just number them. Least, and then the highest number is the greatest. So 1, 2, 3, 4, 5 in that order. All right. pH scale is a way to measure the acidity of a liquid solution. It is based on concentration of positive hydrogen ions in the liquid. Smaller pH indicates more hydrogen ions and higher acidity. Okay, so smaller pH indicates more hydrogen ions and higher acidity. Larger pH indicates less hydrogen ions and lower acidity. Here's a table showing hydrogen ion concentration in moles per liter and the pH of some different liquids. Which of the drinks listed, water, coffee, root beer, orange juice, is the most acidic and which is the least acidic? Okay, so most acidic, so a larger pH is lower acidity, and smaller pH indicates higher acidity. So I'm going to write this here. Smaller pH equals high. Lower pH equals low. All right, that's helpful. So if this is 10 to the negative 7, this is my hydrogen ion concentration, and then this is a pH. So let's think here. So if this has a number of negative 7 as the power and the pH is 7, that makes me think that it's just the opposite of these. So this is 5, 4, 3. And then seawater and vinegar. Oh, it just says which of the drinks listed. Okay. So which one is the most acidic? So the smaller pH is the most acidic. So this one's going to be, smallest pH would be 3. So this is going to be orange juice. Okay. Seawater has a pH of 8. Is it more acidic or less acidic than water? Record the, okay. Let me do this. Let me take this over to the next page. I can add that in here. So it says seawater has a pH of 8. So I'll just add it in here. pH of 8. So that means that the hydrogen ion concentration is going to be 10 to the negative 8. Is it more acidic or less acidic? So the, wait, I wrote smaller pH. I should have said larger pH. Larger pH indicates less acidity. Okay, so when I look at this here, this has a higher pH, so larger pH, so it's going to have less acidity. So water, it's going to be less acidic. All right, vinegar has a pH of 2.4. So if the pH is 2.4, it's going to be 10 to the negative 2.4. So this pH is lower. Lower pH is, smaller pH is higher acidity. Is it more acidic than orange juice? Yes. Because 2.4 is less than 3. Okay. Logarithms used to translate hydrogen ion concentrations to pH values. With a partner, discuss how the hydrogen ion concentrations might be related to the pH. Use words or expressions to describe that. Okay. Well, the sign here changes and it's equal to the exponent. So if we said 10 to the negative pH equals okay, so this equals basically your hydrogen. I'm just going to put H for hydrogen ion concentration. So if I wanted to solve for pH, I'd have to rewrite it in log form. So I'm going to say log base 10, which I don't need to write the base 10, of H equals the negative pH. So then if I divide by -1, we could write pH as a logarithm. pH equals log base 10 of H divided by -1. I could just put the negative in the front. Okay. All right. Table shows the relationship between hydrogen ion concentrations and pH ratings for different substances. Okay. Write an equation to represent pH rating P in terms of hydrogen ion concentration H in moles per liter. So if I look here, if I move my decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like I did, we're really saying this is 10 to the negative 10 equals, 10 to the negative 10 equals 10. So just like we were doing before, it's basically, log base 10 of H equals your negative pH, all right? Because we'd say this is opposite of that. So really it's 10 to the negative pH equals your hydrogen. So this says to use, so I'm going to I already kind of did it. So if I divide by -1, I get here. So we're going to say P equals negative log base 10 of H. Okay, just like that. All right. Test your equation by using the hydrogen ion concentration of a substance from your table as the input. Does it produce the right pH? So I'm just going to pick bananas, and I'm going to type into my calculator. I'm going to say negative log, and I don't need to put the base because it's 10 of 0.000. How many zeros are there? 4 zeros, 1. And I'm going to see if that gives me 5. Okay, I'm gonna see. So I type it in my calculator. You should do the same. Negative log of 0.00001. Sure enough, it gives me 5, so that works. Okay, I could try it with some other ones too if I wanted to. All right, magnesium hydroxide, also called milk of magnesia, is a medication used to treat stomach indigestion. It has hydrogen concentration of 5.6 times 10 to the negative 11th moles per liter. Estimate a pH rating for magnesium hydroxide. So I'm going to use that formula here. I'm going to say negative log base 10 of 5.6 times 10 to the negative 11th. Okay. So here we go. I'm going to type it in. Negative log of 5.6 times 10 to the negative 11th. And what do I get here? And I got, what did I get? Why did I not get the right answer? All right, I'm going to type it in again here. Negative, and I got negative log of 5.6 times 10 negative 11. So, okay, there we go. Now I got it. And that's going to give me 10.25. Okay. As shown on the table, apple has a pH of 3, and milk has a pH of 6. How many times more acidic is apple than milk? So, how many times? So, a lot of people think it's, twice as acidic because it's double the pH, but that's not really how it works. So, I'd have to figure out how many times more the hydrogen concentration is. So, we're looking at an apple and milk. So, here's my milk. Here's my apple. So how many times more? So if I did 0.001 and I divided it by 0.000001, I get 1,000. Okay, so it's 0.001. I have to do the hydrogen ion concentration. All right, here's another one. Here's a table showing the Richter ratings for displacements recorded from earthquakes. So here's your displacement. Here's your Richter rating. Okay, compare an earthquake rated with a magnitude of 5 on the Richter scale that was rated with 6. How do their displacements compare? What about an earthquake with magnitude rated 2 versus 3? Okay, so let's take a look here. So earthquake with a magnitude of 5. So that's right here. Versus an earthquake with a magnitude of 6. So how many times bigger? 10 to the negative 1 is 1/10, and this is 1/100. So that is going to be 10 times as great. Okay. So 5 versus 6 is 10 times. 6 is 10 times as great. Okay. What about an earthquake with magnitude 2 and 3? So 2 and 3, so this is 1 over 10 to the 5th versus 1 over 10 to the 4th. So basically, if I times this by 10, that's going to cancel that. So the same thing. So 5 versus 6. And so in between every one of these, it's 10 times greater. So that would be 2 and 3. Ten times greater as well. Okay. All right. Discuss with the partner how displacement might be related to the Richter scale. Express the relationship in words or an expression. Okay. So what we could say here is the rating is 7 higher than the exponent of the power of 10. That measures the displacement in meters. Okay, so 7 higher. So if you notice here, the 5 is 7 higher than that power. The 6 is 7 higher than the 1. The 7 is 7 higher than 0. Okay, so you should have noticed that maybe by kind of analyzing it there for a little bit. So what is my function here going to be? So it's going to be r equals 7 plus log base 10 of d. Okay. Number 3, an earthquake shook the northwest part of Indonesia in 2004, causing massive damage and casualties. If the seismograph was located 100 kilometers from the epicenter, it would have recorded a displacement of 125 meters. Use the answer to the previous question to estimate the Richter rating for the earthquake. So here's my formula. So my displacement's 125. So I will plug that in. Calculate if you want to get a decimal. So log of 125 plus 7. So I'm going to get the rating of 9.097. All right. Why not use measured quantities to report, say, acidity and earthquake strengths? In other words, why use scale rather than the actual measurements? Okay. So here's what I would say. I would say when the numbers used to measure the quantities are either very large or very small, or both, I guess, using a different scale helps show them together and make more sense of them. Okay, so you had those like 10 to the negative power. It was like such a small decimal. Didn't really make much sense. Okay, next one. What kind of quantities can be better instead of expressed in terms of logarithms? So obviously exponents that we are looking for are better expressed in logarithms. For what quantities are log functions not needed or helpful? Quantities where there is a lot of variation. I'm sorry, where there is not a lot of variation. Okay, that's when they're not needed. When they're not needed. Sorry, I read that wrong. For what kind of quantities are log functions not needed? So they are needed when there is a lot of variation, but if they're not needed when there's not a lot of variation. Okay, and let's take a look at this last one. All right, the expression negative log H represents the pH rating of a substance given its hydrogen ion concentration H in moles per liter. Water has a hydrogen ion concentration of 10 to the negative 7 moles per liter and a pH rating of 7. Apple juice has a pH rating of 4. Select all true statements about the apple juice. Okay, it has 100 times the hydrogen ion concentration of water. Well, we would have to check out. All of this is in hydrogen ion concentration. So if it has a pH rating of 4, your hydrogen is 10 to the negative 4 for apple juice. And water, they told us, water is 10 to the negative 7. So it has 1,000, apple is 1,000 times greater than water. So I would say yes, if I took this times 1,000, 1,000 is really just 10 to the third. So yes, if I multiplied this, I'd add the powers and I'd get what I have. So that's true. The next one, it has 3 times. So that's obviously, if we said it's 1,000 times, that's false. Has 1/3, that's false. Has 1 over 1,000, that's false. It has a hydrogen ion concentration of 1 over 10,000. So 10 to the fourth is, what is 10 to the fourth? 10 to the fourth is 10,000. So it'd be yes, 10 to the negative 4 is 1 over 10 to the fourth, which is 1 over 10,000. So this one's true. Cleaning solution has 1 over 100,000 of a hydrogen ion concentration of water. What's the pH? So this is going to be 10 to the 1 over 10 to the fifth, which is 10 to the negative fifth, which I changed the sign of that, which would mean my pH is 5. Okay. All right. That's it for this lesson. Hope you enjoyed it. Thanks for watching. We'll see you on the next lesson.